But now whatever we discussed till now, weight by volume. So I want to discuss here the conceptual questions which they are asking in the exam में, from the weight and weight by volume में. 1 second. Yes. Suppose a solution of HNO3 is there. A solution of HNO3, if it is 5% weight by weight, find the mass of find the mass of HNO3 present in 100 ml of solution whose density is given as a 1.4 gram per ml. See, beta, this is a question we are able to solve only if we know, the concept of weight by weight and the concept of weight by volume. See, weight by weight is given and mass of HNO3 they are asking. So we can write the formula. Weight by weight percentage is equal to weight of solute. And do you know, beta, in this case, weight of solute is HNO3 by weight of solution into 100. Beta, in this one, 5% means we are having 5 gram of the solute is there. But they are asking the mass of the HNO3 in 100 ml of solution. They are asking that the mass of the HNO3 in 100 ml of the solution. So if it is a 5% W by W means directly we can say ki that means 5% is a W by W over weight of solute we have to find out and weight of solution we want. What is the weight of the solution we'll try. Just a minute. Sir, W by W percentage means we can say it is a 5%. It is equal to weight of solute means that is the weight of HNO3 we want by weight of solution we want. Weight of solution I want. How to get the weight of solution? Already I told you. It is based on this concept. Density is equal to mass by volume. And you know, mass is equal to density in volume. Now, density equal to mass by volume. Mass is equal to density into volume. What is the density we have? Density we have having 1.4 gram per ml into volume of the solution. See, 100 ml is given. It is given here 100 ml of the solution. That means ml get cancelled. The mass of the solution I am getting 140 gram. So it is a mass of solution I got as a 140. Then into 100. And you solve it, will get the answer. The weight of solute is equal to 140 into 5 by 100. That is equal to 7 gram. Right? 5 ones are, 5 twos are, 2 sevens are. So weight of the solute we are having how many? That is only 7 gram. So this is one of the concept which one we did about the weight of solute and all. So I want to go with one more concept after the weight by weight and all. The next concept is that what is a mole fraction? It is also coming under the part as a temperature independent. Now we'll see about the what is a mole fraction and how to calculate it. Right? But mole fraction is denoted in the form of x. Let me tell you. Suppose if we are having a solution which is made up of a two component, component 1 and component 2, then the mole fraction of component 1 and component 2 is always be equal to 1. Means what is the x1? x1 is called as a mole fraction of component 1. Let us consider beta component 1. I will take it as a solvent. So what is the X2? So X2 will be considered as the mole fraction of solute. One is a solvent, other one is a solute. Chalo, X1 is a mole fraction. So mole fraction of all the component in the solution should be equal to 1. Means this is a one of the container is there, and this container may I am having a solute and I am having the solvent. Sum of the mole fraction of solute and solvent is always be equal to 1. Now question is that how to calculate the mole fraction of the solute. X1 is the mole fraction of solute. How to calculate? With a mole fraction of solute, that is X1, it is equal to, or solvent, that is equal to N1 by capital N. And how to get the X2? Either we can use N2 by capital N, or we can say X2 can be written as 1 minus X1, because we know the sum of the two component is equal to 1. So X2 is equal to 1 minus X1. What is this small n1 and capital N1 indicate? Let me tell you what I here. This one equal to N1 by capital N is a total number of moles of all the components. So value of N1 plus N2 is equal to N. So let me write here. What is the N1? N1 is called as a number of moles of solute. Sorry, one is a solvent. I'm confusing here. But one is a N1 is a number of moles of the solvent. N2 is the number of moles of the solute, right? So N1 by N1 plus N2. Suppose they didn't give the value of N1. So we can find out N1 is equal to, that is a number of moles of solvent is equal to weight of solvent by gram molecular weight of solvent. So I should write W1 is the weight of solvent and M1 is the gram molecular weight of solvent. Same way, if N2 is there, if N2 is there, N2 is equal to W by M2. What is the N2? Number of moles of the solute. So W2 is the weight of solute and M2 is the gram molecular weight of solute. Right? Now go with one examples here, because this is the formulas whatever we wrote. Now we'll go with some examples here. Example, see once again check the formula what we wrote. We wrote here formula. Mole fraction denoted as X. X1 plus X2 equal to 1. X1 is the mole fraction of solvent. X2 is the mole fraction of solute. Sum of the mole fraction of solute plus solvent equal to 1. X1 equal to N1 by total number of moles of the component. This is there na. Capital N is a total number of moles of all component whose value equal to N1 plus N. And N1 is number of moles of the solvent, N2 is number of moles of the solute. Based on that weight of solute solvent, gram molecular weight of solute solvent, we wrote. Chalo, one question we'll do based on this part. Sir, we are having a 40 gram of NaOH is dissolved in 36 gram of water. Calculate mole fraction of NaOH and mole fraction of water. So better now directly they are asking to get the mole fraction of NaOH. Do you know number of moles of NaOH by total number of moles of all the component, that is NaOH plus water. Sir, get the number of moles of NaOH. Weight is 40. Do you know what is the gram molecular weight of NaOH? Beta, it is equal to 40 gram per mole. So it is also 40. The number of moles of NaOH is 1 mole. How to get number of moles of a water now? Number of moles of water equal to weight by gram molecular weight of water, you know. It is the 18 gram per mole. Sorry, 18 gram per mole. So 36 by 18, it is equal to 2 mole. So mole fraction of NaOH is equal to 1 by 1 plus 2, 1 by 3. Then mole fraction of water, it is a 1 minus mole fraction of NaOH. 1 minus 1 by 3, that is a 2 by 3, is a mole fraction of water, right? So we'll try to do some more examples in different way. Question is given here. A solution has a solution has 46% weight by, sorry, not the volume, because already volume में confusion will come. I'll do weight by weight beta. A solution has 46% weight by weight C2H5OH. You know, it will be called as a what? Ethyl alcohol, and that to be in water. They are asking calculate mole fraction of ethyl alcohol and mole fraction of water. See, beta, will try it. Very simple. Uh, Now, I want to get, see, 46% weight by weight ethyl alcohol in water indicate that first weight of solute. Do you know ethyl alcohol is a solute 46 gram. Then second, weight of solution, that is percentage is given 100 gram. Sir, solvent, weight of solution minus weight of solute, that is equal to weight of solvent 54 gram. But in this case, solvent is a water. You can check in the question they gave the water and solute is a ethyl alcohol. Now we can reach for our question. Sir, mole fraction of ethyl alcohol equal to number of moles of ethyl alcohol by number of moles of ethyl alcohol plus number of moles of water. Can you find out with the number of moles of ethyl alcohol? It is a weight of the ethyl alcohol given as a 46. Gram molecular weight of ethyl alcohol also 46. So 1 mole. Number of moles of water 54 by 18. It is a 3 mole. So it is equal to 1 by 1 plus 3. So mole fraction of ethyl alcohol is 1 by 4. That means mole fraction of water, it is a 1 minus 1 by 4. That is a 3 by 4. We are able to calculate mole fraction of ethyl alcohol and the mole fraction of water.